Okay, morning everyone. Let's get started. So today we're gonna quickly go through the remaining part of the course policy, and then we'll give a quick review of the basic knowledge, which would mostly cover the problems that are homework 0. So some students ask me, like, if we're gonna cover every detail of homework 0. Unfortunately, we're not going to do that. So homework 0 was released to intentionally stimulate your memory, right? Your past experience or knowledge about, all those foundations you have learned from your first year or second year in college, like basic statistic concepts. What's the definition of expectation, conditional expectation? What's the definition of integration, right? All kinds of stuff. And we do recommend you, like, if you feel some concept is weak or not very clear to you, just find out your textbook or search on Google, whichever way you feel convenient and comfortable. This is just to strengthen your idea or knowledge about this mathematical foundations, because the following content are based upon those things, right? We don't want to let you feel lost when we introduce relevant stuff. Okay. So in the last lecture, we talk about the course project, right? There's one section in our course website talking about every detail about projects. So we're going to walk through that. Actually, we were in the half of that last lecture. But if you still miss some kind of details, you want to get clear about everything, so please go to the course website and check out this project, right? Just click that and you lead to this course project, and it includes every detail. Okay. So as we mentioned in the last lecture, we're gonna have two possible types of projects: competitive project and an exploratory project. Competitive project, literally, we're doing some in-class Kaggle competition. So we'll open that Kaggle competition by the end of this week. And then you're going to have a chance to look at what is the task and what is the basic setting of about that. And you can make a decision. And for the exploratory project, is some kind of research or open-minded project where you can pick up any problem you feel interesting to solve it and use machine learning, right? So for the competitive project, you can only do this solo stuff, meaning that you cannot form a team. You are in charge of inventing new solutions, submit your solutions, then let them rank by yourself, right? For the exploratory project, you can form a team, but at most size of 2, meaning that you can find another team member if you like. So both projects are grades in 4 milestones, which we have covered in the last lecture. I'm not going to go through that again. But again, some students might be concerned that, okay, what if my prediction accuracy is less than 99%, right? Or if my rank in Kaggle competition is not top, will I get deductible? Will I get deduction in the grade? The answer is no. Right? So don't worry about that. What we really care is that whether you really engage yourself in exercising machine learning in the particular problems you want to solve, right? And as to whether you're really successful in solving that problem, or you're doing mediocre or even failed, it doesn't matter, right? So as long as you try everything, and also report your results following our request, we list items which we want to see in your project reports, and also want to see your source code in your private GitHub repository, then it's very likely to get a full grade, right? So don't be worried about, you don't need to worry about whether you're doing extremely successful course project. That's not a requirement, right? So but of course, if you're doing well, especially for the competitive project, if you rank on top, you're gonna have several bonus points, both in the midterm and in the final, And again, there's one thing I want to emphasize, that in the final report, you must include a GitHub repository links to your implementation of your project. Right? So if you don't include that, you won't have you won't receive any point in your final report. The reason is simple. I mean, we're not only going to check your report content, we're going to check if you really implement what you report in your report, right? So this is just to avoid like someone might feel, okay, I'm just fake a report, right? That's not allowed, right? So we want everyone to really do that, right? And your implementation should match your report. Right? And also, if your projects involve experimental evaluations, I guess the 99% of projects will do that. You're not doing a pure theoretical research, then you should list details about experimental evaluations, should be rigorous. You should choose fair baselines. You shouldn't just use random prediction as your baseline, right? At least you should compare with linear regression or linear classifiers, right? You should apply cross-validation, which we're going to discuss later, for hyperparameter selection, and report both positive and negative results. Right? This is actually important to gain some real practical experience, right? So I know that right now, like in research domain, like people tend to not report negative results, just leave positive results because they're scared of being criticized and being rejected by the reviewers, right? But this is not good because no method can work the best in every possible scenario, right? And that's why, like, in the recent years, like top venues in machine learning, they're encouraging authors to expose the limitation of their methods and also their plan to address those limitations. I think that's a good trend, right? And bonus for competitive project, right? If you by the deadline of the report, don't submit. If you want to get bonus, don't do the late submissions, right? And the top 10 ranked students will receive 7 bonus points. So someone might feel like feel lost or don't have any clue about how to choose topics if you want to do exploratory project, right? So basically you can choose whatever problem if you're interested and if you potentially can be addressed by machine learning, right? So it's up to you to choose the project topic. And here we just give you some example, right, to motivate your thinking, right? So for example, you can choose an application project, right? You want to apply machine learning technique to address some problems. Like previously, I got one student is doing like half working, half taking the class. He works at some company. They want to kill mosquitoes. I forgot they use drugs or whatever devices. They want to kill the mosquitoes. So he wants to predict the activity of mosquitoes. Right? He used neural networks and convolutional neural nets. And that's a fantastic example. Right? You can use such kind of problems, very, very practically valuable and very and very interesting, right? Application project. Or if we want to reproduce some published results, right? So there are like a huge number of papers published every year. If you're interested in one particular machine learning paper, you want to know all the details, you can choose to re-implement their method and evaluate with the same experimental setting and see if you can reproduce the results, right? So the reproducibility crisis has been proposed for quite a few years, right? Because nowadays, like, data is so huge and the experimental setting is complicated, right? There are a large number of hyperparameters you need to tune for the neural networks. Like many researchers are complaining that, okay, why I can't exactly reproduce the results claimed in those papers, right? So reproducibility issue is really important, right? Okay, theoretical project, right? If you're saying, okay, I'm a theory guy, right? I want to prove theorems. I don't want to do any experiments. It's totally fine, right? Pick up some problems. You want to like make some proof and write it in the report. That's also acceptable. And in that case, like we won't grade your experimental part. We're gonna combine your methodology part and experiment together to give the grading. Algorithm project, right? So if you want to develop a new learning algorithm for a particular type of problem, for example, we know that neural networks, all the model neural networks are trained with backpropagation, right? But right now, Jeffrey Hinton is like kind of like founding father of this artificial neural nets research. He claimed that he wants to develop a new training algorithm which does not need backpropagation. They call it forward propagation algorithm. He said that that is more closer to the real intelligence, right? So of course you can do that. I mean, it's not necessary to be like a fundamental transformation of the current paradigm. You can just look at some algorithm. You feel like, okay, there's still space to improve. I want to improve it by adding some kind of trick. I can reduce the complexity from n cubic to n square or n log n. Right, that's also very good, right? And fifth example, maybe your own research, right? So we also mentioned that in the last lecture. So if you're a PhD student and you're working on some project and you feel like, okay, it might get some fancy results by applying machine learning method, and go ahead to embed your PhD research in your course project. I think it will be very beneficial for you. So in general, choose topics that feel exciting and convince me that topics important and interesting. That's your job. If you want to do exploratory project. And here are some like concrete examples of exploratory project. Right, the first one is this link to Kaggle computation task. Right, so that's something I highly recommend you to walk through this Kaggle platform. It's like world's largest data science computation platform. It released like a tremendous amount of data sets and the tasks. You don't necessarily follow the tasks they define, right? You can pick up their data set or subset of their data and define your own task, right? And walk through those problems and data sets, and let's see whether they can inspire you, right? Or some other particular tasks like biological and medical study, right? Can we select genes relevant to some disease, such as breast cancer, Alzheimer's disease, learning to play board games like checkers, settlers of Khartoum, etc., right? Predict store market price, right? And you can try that. I can tell you the results, and I've given my past experience. This project has never been successful, right? Yeah. This if you succeed, please share with me your secret. Yeah. And detecting sarcasm, hate speech, humor, irony, metaphor, etc. in text, right? So this is also a very hot topic in natural language processing, text mining, right? And you can try to leverage, say, the popular large language models, right? Right now it's very, very hot, right? And build up some classifiers or sentimental analysis technique on that. That'll be very exciting as well, right? Classify a run of song, book, movie, and painting, right? Very popular tasks in recommendation, right? Recommend products, right? Can we use customers' purchase records to recommend commodities to old and new customers? So there's a Netflix challenge, right? There's some data set on the web, it's very popular. Software security, right? If you're doing some network security or security research, you know that how to identify malwares, right? Malware or malicious apps is very important. You can try to use machine learning to solve that problem, right? And spam emails detection, that's an old classical problem. Like nowadays, if you log into the Gmail, right, If you don't use spam email filtering, you will receive a lot of fraud emails, spam emails, like every day, every time, right? Every minute. Okay, any question regarding course project? Great, that's really great. Again, if you want to clarify something, want something to be clarified, or you want to check out the details, don't forget to look at the website first. Right? It contains everything, right? So, so this is the home of the website information, and these are kind of like overlap with the with our syllabus. So I'll just leave you guys to check, right? So these are topics, which is also the same as what we listed, syllabus. And then I believe the most important page in this course set is the lecture section, right? So we're gonna live stream the lecture, every lecture, to some YouTube channel. It is called UFU Data Science or UFU Data Channel, right? If you choose not to sit in the classroom, and if you want to watch the live stream, you can just search on the YouTube and search the UFU data. They're gonna with the starting of the class, the live stream will pop up. You just take a look, but just be careful. You won't be able to ask questions during the class, right? During the live video, right? And also after the class ends, I'm gonna paste the link of the video in this course website, in case that if you want to review things, right? You want to rewatch the lecture video, I click into that. And also our lecture slides will be shared here, right? We'll post our lecture slides before the lecture, right? In case that some students want to take a quick view of the content before they start the class, right? It also provides the resources for you to review. Okay. Any questions so far? Okay, great. So now let us go back to the syllabus. Okay. So I think we have went through the necessary content. Yeah, it's this about course project, and find that we spent quite amount of time talking about course project, which takes in total of 30% of final grade. Right? Then we'll have one final exam, which takes about 20%. It's relatively small as compared with the homework assignments and the course project. Right? But we do need some final exam, right? And it's open book. You can bring whatever materials that you think will help the exam. If you are doing in-person exam, right? No computers, cell phones, or tablets are allowed doing that. If you're doing online exam, you have to use computers, right? You need to access the online campus exam. And but we encourage you not to use cell phones. But later we'll see that. I mean, if you take the online exam, usually you don't have enough time to use your cell phone to text your files, right? Or post questions on, say, Quoral or Stack Changer or something. There's a popular question and answer website, right? So we intentionally make this final exam open book is that because I never believed that hard memorization of those content will be helpful. We request you to really understand the content, right? That's why our final exam will just to look at whether you really understand some concept, rather than ask you to memorize the particular threshold error steps or form of the generalization error bound. That's not something we're looking for. So that's why we encourage you to use open book or write some cheat sheet. It's totally fine, right? But if you don't understand the basic concepts, I bet that even you bring all the materials, you might still feel challenging or confusing. Okay, letter grid mapping, right? So we know that we eventually, the transcripts, you show up with letter grade rather than numerical grade. So I have some standard to convert the numerical grade to the letter grade. So we have two tables, one for 5350, the other for 6350, right? So because this is kind of a hybrid of undergrad course and graduate course, right? So for undergrad, we have a lower bar to get A, B, C, and so on, right? For undergrad, because you are more senior, you will need to do better to get the same level of the grade, right? And someone will ask, well, what if my score is not some integer, right? What if my grade is 88.5, right? So we'll do round up first, and then map the numerical grade to the letter grade. Like for example, for the 6350, if you got a numerical grade between 90.5 to 90.9, we'll round it up to 91, right? So that means you got A, right? But if unfortunately you got 90.1 to 90.4, you're gonna run up to 90. That means you're gonna A minus, right? So if you, after you get a numerical grade, you will see that in the canvas. And of course, we'll convert them into letter grade. But if you do feel like, okay, I should be able to get 0.5 more or even 0.3 more, I want that additional points so badly, feel free to contact me so I can walk through all your homework assignments to find out if you can find additional points to add in, right? But if we failed, then you are where you are, right? So we're gonna just execute our policy into to get your final letter grade. Okay. Final exam on Friday, December 15, from 8 to 10 a.m. And if you're doing in-person exam, it will be exactly this classroom. And if we do an online exam, you just sit in front of your desktop, right, or laptop. Right? Lead policy. Right? So the assignments will be turned through the canvas by the designated deadline, right? As usually Friday, 11:59 p.m. Right? If you want to receive the full credit, right? If you miss the deadline, right? As long as you miss the deadline, the late submission will incur 10% penalty, and after every subsequent 24 hours, you will lose another 10% of credit. Okay? And unfortunately, we won't accept late submissions like more than 48 hours. Okay? So that means you can submit your homework like within 2 days after the right deadline with some penalty, right? But don't try to submit like 3 days later. That won't give you any points. Right? And we usually at least have 2 weeks to finish homework assignments, which we believe is sufficient. So really, we won't make extensions, right? And if you have something in you, right? You have some emergency, you want personal extension, please let me know, right? And to be fair to all the other students, we usually request you to give some document, like doctor's notes, witness notes, something like that. Right? That's just to be fairness, not to say like we don't trust you. That's not that. We just want to be as fair as possible. Right? And sometimes you may feel like, okay, I should get a higher grade for my homework too, right? So why I got this actual deduction of the points, right? You might request regrading. That's fine. Yeah, that's our. I think that's totally reasonable. So please request a regrading within 1 week of receiving your grade. Like if you receive the grade and you say, okay, this grading is unfair, it's problematic, is incorrect at some part, send me an email first and pointing that, okay, I feel the points they're giving me is incorrect, is too less, is too small, right, anymore, and give me the reason. And then I will forward your email to the TAs, and TA who in charge of grading your homework will relocate and will negotiate with you. Okay, but please be aware of the timeline, right? So we request you to, like, if you want to regrade, please do that within 1 week after you receive the grade, right? It's not fair to ask the regrading like at end of semester, right? After 1 month or 2 months, you have received your grade, right? If you after 1 week, we believe that, okay, you think this grade has properly reflect what you have done, right? Any questions so far? Graded one. It will be put into the final grade. Any other question? Okay, so homework submission, right? So typically, your homework submission will be some compressed file, including some PDF and some code, right? Some implementation, right? So the PDF, that is the written part of homework, should be done with LaTeX, right? So this is something that everyone should know for research and writing scientific and engineering documents, right? So if you have never, how many of you have used LaTeX before? Oh, yeah, I'm glad to see most of you haven't heard of that. Yeah, so if you've never used that, don't worry, don't panic. It's very easy to use. And we got some linked directory here. It contains the sample.txt file, right? And very easy to find the documentation or tutorial about how to use LaTeX. Plus, every time when we release our homework, we release the LaTeX source file. And it is compilable, meaning that it is working normally because I use that to create the homework, right? So, and you can use online LaTeX editor, which is called Overleaf, and just to paste this LaTeX source into the Overleaf and create a new document, right? It can automatically compile that for you, and you just add it, type your solutions into the text file and compile it. You can do that in real time. You don't need to install any LaTeX editor, compiler, all kinds of stuff. So it's very, very convenient. Okay. And don't use handwritten document and take a picture to upload, or use Word to add it to your document. This is something we don't receive. We don't accept. Okay, and try to use LaTeX and try to learn that very quickly. It's not hard at all. Yes, you submit PI. We don't need to look at your LaTeX source. Yeah, you just use LaTeX to compile that and submit that. And looking at the PDF, we'll know that whether it is written by LaTeX or not. Right? If you use Word, the equation, the formulas are so terrible, right? And it's really bad, right? And if you use LaTeX writing math formula, it's very convenient and it's very good looking. Any other question? In principle, we don't restrict any programming language you're going to use. Although we highly recommend you using Python or MATLAB or Jupyter Notebook. Especially when IPython is very welcome because it's very convenient. Right? We just don't recommend you to use like low-level language like C++, C, or Java. That will cost you too much time and doesn't really meaningful. Yes. Yeah. Just make sure that you submit your code and give some simple document. Tell us how to run your code. And that's it. Yeah. If you use Python, it's very simple. You just say readme and give me a command line to write your code, to run code. Any other question? Okay, great. Attending final exam, right? Occasionally, I know some students, they have like emergency, right? They have to skip the final exam, right? So if you're unable to take the final exam at a scheduled time, please contact the instructor ahead, and I might be able to schedule some another time for you, right? If you miss the final exam due to emergency, please notify the instructor within 3 days of the exam and provide the proof document. Again, this is just to be fair to all the other students, right? And then we can consider scheduling a makeup exam. Academic policy, well, this is, I think everyone knows that. Don't cheat, don't plagiarize others' results. And one thing everyone should be aware that the Canvas system, we build up a huge database. They're gonna store all the submissions, all the previous submissions, right? So I know I definitely not you guys, but in past experience, there are some students like pretty much sure they kind of copy the implementation from the previous class. I don't know how their previous implementation kind of like spread it, right? And then it was found by the Canvas system. They're gonna give me some warning. Then we can take a look and we can even do the comparison and do that, right? So it's pretty powerful. So don't do that. And if you have to investigate whether you're gonna plagiarize, you have plagiarized something, right? We might need to meet with you and give some warning or even 0 grade for the exam, right? If things got severe, then it's very bad anyway, right? So do it by yourself. And usually if a student is caught cheating on the homework or test, they will receive a failing grade for the course. And right. And of course, I mean, there could be some back and forth debate on that, right? But I do not want to involve any such kind of debate or conflict in that. I hope everyone is no one is going to do that. Okay. Collaboration policy. So this is something we have discussed before, right? So for assignments, you are encouraged to talk to each other offline. I mean, you can form some study group and find some meeting room and discuss possible solutions, contribute idea. It's totally fine, right? And for the on-Canvas discussion, you can also talk about the rough solutions, but you cannot post the solutions or code to the Canvas. Right? You can talk about the ideas, like for example, how do I prove the last problem in homework 0? You cannot just post your LaTeX written document, right? You can say, okay, I believe we can use several properties of LaTeX, several properties of convex problems, like for example, if a function is second order differentiable, then if its Hessian is positive definite, then it must be convex, something like that, right? But you cannot say, okay, I will give you exactly steps how to show that this Hessian matrix is positive definite. That's not allowed, right? And in the offline study, you can do that because you guys are really interacting with each other, right? And there could be some consequence that, okay, because you and your friend are talking about the solution of exam, and it turns out that your written solution is kind of very similar. To avoid, we kind of like misunderstand that, right? Please add some notes in front of your submission and saying that, okay, I collaborated or discussed with someone, and we kind of reached the agreement to solve some problems. So don't be surprised that our solution or written is kind of similar, right? Otherwise, we'll have to like, okay, I feel like, okay, you two might be cheating, you both will get 0 grade. Okay.
We use Copilot.
Copilot. No. No. Yeah, don't use artificial intelligence technique to help you write code. That's not a lot. Right? Other questions? Okay, great. And if some students are physically challenging and need some additional help, please do not hesitate to contact me. And also our university is offering all kinds of like facilities and convenience for you to make you feel like comfortable and more adaptive to our class. Okay. So far, any question regarding the cost policy and the requirement, all kinds of stuff? I'm open. I'm happy to answer any question. Okay, great. So yeah, thanks for bearing with me. I spent a lot of time introducing the details. I just want to make everything to be explicit, right? So to give you enough time to make the choice, right? I really hope after this class, everyone feel like I got what I want, right? Rather, okay, I really hate this class. I got suffering from this class. I'm tortured, and it's really frustrating. I don't want to get that, right? So that's why I'm trying my best to deliver all the details of this class requirement, expectation of this class. Hopefully, you will make your own choice wisely and comfortably, right? So now let's go back to the slides. Right. Yeah, we just return to the previous point, where we show where's my homepage, where's the course website. We have went through the course website and syllabus details, right? So again, emphasize, this is just to stress on the overall goal of this course, right? We focus on underlying concepts and algorithm ideas in machine learning. This is an introductory level of machine learning course. This course is not about using some specific machine learning tool like PyTorch or TensorFlow, although we're gonna schedule some guest lectures to give some tutorial about that, but that's not our major topic, right? And we're not gonna focus on any single learning paradigm like deep learning. We got a deep learning course in our department. So if you want to further study on that topic, feel free to register that class. I highly recommend. Yeah. How we will learn? First of all, please take classes in person to learn the models and algorithms, right? I know later, perhaps like the first 2 weeks will be the we'll have the most attending students, and then less and less students will join the class in person. But I'm gonna still advocate the benefit of joining the class in person. The reason is that if you stay in this class, you really listen to me, you're very unlikely to be distracted by other stuff, right? You're highly concentrated on what I'm talking, and you're free to interrupt me and communicate with me at any time. So that will be very, very extremely efficient for you to understand this class, right? It's not wise to like skip the class and look at the slides, right? And spend a lot of time then look at and drag the YouTube videos. Believe me, that's very, very inefficient, right? So I know everyone is very busy. You're multitaskers. You need to do your research. Or you need to finish another 10 classes, right? That's why not just be as effective as you can to do this, right? Rather than waste your time, right? And finish homework assignments to deepen understanding. And this is something I want to emphasize again. Don't try to finish your homework assignment at the last day, right? That won't be sufficient, right? Maybe you can do that for written problems, but won't be sufficient for programming problems. Right? This class is not like many other classes. I give you an algorithm table, just fill the blank, and that's it. It's not like that. You have to implement those algorithms from scratch. You have to test them, you have to debug them to make it work on some small, though real-world data sets. So believe me, in your mind, like you think you really know this, it's different from in practice, you can implement and make it work. There is a gap on that. So you need some time to fill the gap. So don't try to fill the gap in one day or in a few hours. That won't be sufficient, right? And that will also make you unnecessarily panic, right? Unnecessarily. Yeah. And also do the homework as early as possible so that you can stop by our office hours early. So we got office hour every weekday. So don't waste office hours from Monday to Thursday. Don't join the crowd office hours on Friday, right? That will make you have much more resource, right, for helping. And implement the learning models and with myself and doing a course project using machine learning techniques to solve problems. And also please be aware of the campus notice, right? We might have some announcements from time to time. And feel free to post the questions and discuss. And our TA and TMs will respond as fast as they can. But just be aware that they might not be able to respond to you immediately at like 10 p.m. or in the weekends, because they are students as well. They have to finish their class or their PhD work or thesis, right? So, but during the daytime, I'll ask them to watch your questions and try to respond as soon as they can. Workload, 6 homework assignments, most including, except homework 0 is just help you review the basic math. The other 5 homework assignments, each of them has both the written assignments and programming assignments. And you got course project, and we need midterm project and final project and your GitHub repository for your project implementation. That means you need to do a lot of programming, and I got 1 final exam. That's total workload, right? And here I put this warning message in red. This course perhaps is one of the most challenging courses in the CS department. The workload is heavy. There were some past students complaining that it can take about 20 hours per week. I don't want to scare you. This is some single point, some outliers, not like the yeah, question.
Would you say that, like, on average, it'll take 20 hours a week, or is it like,
yeah, there's something I want to explain right now. Yeah, so it's not on average. Look at what I said. Past students, some past students have complained that. I guess that students were kind of frustrated about this class. That's why I repeated asking you guys to think carefully. I'm saying that the workload is heavy. It's pretty heavy, actually. And I've received some complaint, but it's not like a universal complaint. I just 1 or 2 complaints that, okay, I'm too busy and it takes too much time and take me 20 hours per week. But I do see a lot of students say, okay, this class is very effective. I can do it like within no more than 6 hours per week or 7 hours per week. We have a large variety on that. I'm trying to give you the worst case for you to give you some kind of reminder, not to scare you, right? And for my own understanding, my own experience, like I've taught this class for 5 years, right? Most of the students, they won't take like more than 10 hours per week, right? But there are some cases, like some singletons or outliers, like they feel quite challenging or difficult for this class. That's why I encourage you, like, let me know if you feel really okay. I can't hang on, right? I need to quit. I want your signature or something, I'm totally open to that. But please let me know. Don't drag it until like end of semester. That won't be good for you, right? And again, if you feel challenged, if you panic about it, let me know as early as possible. We can figure out a way to address that, right? We can figure out, okay, if it's just we're not totally adaptable to this class, or you just like temporarily feel it's difficult, but you can get better and better. I've seen these cases, both cases before, right? We have some kind of strategies, right? But just let me know your concerns as early as possible. Don't be shy. Right? Any other question? What? Well, maybe I should do this survey, right? Otherwise, I cannot give you the big like variance. We don't have we haven't done that, so but yeah. But usually I would tell like 2/3 of the students in this class get A or A minus, right? A minor portion get B, and very few get C or even D, something like that, right? And again, this is not a class like intentionally, like designed to intentionally fail you. Just want to, it might challenge you sometimes, but if you can work through that, you feel it worth your efforts, right? But again, if you feel like difficult, feel challenging, feel concerned, just let me know as soon as possible. Other things like me, other concerns right now? Okay, perfect. So we're going to give a quick basic knowledge review, which might cover part of the questions we in homework 0. Right? But again, to do the homework 0, you should already started doing that. Don't try to finish that on this Friday, right? So we're going to first go over the basic concepts about the probability, right? So we know in practical world, many phenomena, many experiments are random in nature, right? So we want some mathematical structure, mathematical term to characterize those randomness or reason under this randomness, right? So that's why we start with some basic definition or representation of random events and the probabilities, right? So we usually use sets to represent random events, right? And each element in the set is some kind of atomic outcome. For example, if your random experiment is to toss a coin, say for 5 times, right? And the outcomes of interest is whether you see the heads up or tail up, right? So then we can use a set of size 5 to represent your outcome of the random events. So for example, even A would be, 3 heads and 2 tails, right? That represents one outcome of the random event, right? You toss a coin for 5 times. Or even B, which is another set, contains tail, head, and tail, right? Which is another event, right? So to measure the chance of different events, we kind of assign a probability, right? So rigorously speaking, there should be a measure function which measure sets of collection of sets to probability, which is between 0 and 1, right? So we use probability to measure the chance for a particular event to happen. Like, for example, if I want to know what's the chance that event A happens, I denote this chance by P of A, right? So we denote the chance of B to happen by P of B, right? And also we can create new events by doing set operations. Right? For example, if I do the intersection of between A and B, right? We're actually creating a third event. That event means that both A and B happen. And when I do this union, right? A union beam, I create a fourth event. And this event, it just means, oops. It just means A or B happens. So you see the subtlety here, right? A union B is different with A intersection with B, right? So conceptually, a union B means A happens or B happens. I mean, A can be like A happens, B not happens, or A not happen, B happens, or both A and B happen, right? That's what the events that A union B represent. But for the intersection of A and B, it means both A and B must happen. And there is a simple formula to express the relationship. That is, the probability of A union B is represented as P of A plus P of B subtracted by P of A intersection with B. Okay? So this can also be represented by the Venn diagram, right? So we know that, suppose this area represent the probability that A happens, right? And another circle's area represents the probability that B happens, right? So what is the probability that A intersection B? A and B, yeah, in the middle, right? The overlapping part, right? So what is the probability that A union B of A union B? Yes. Yes, you just union them, right? And look at the total area, right? That will be something like that, right? And from this graph representation, it's very easy to get to the formula, right? The union of A and B's area is equal to the area of A, right? The area of B, and of course, you actually when you add them together, you actually add the overlapping part for twice, right? That's why we should subtract them by the overlapping part, right? Okay, and we got some general version. Like suppose you got A1, A2 to AN, right? And if you want to compute the probability that A1 union A2 to A until AN, right? We got a general formula of doing this, right? So I'm not gonna write down the formula. It's quite complicated, but it's simple in the structure, right? So you can check out your probability book or statistics book, right? Okay, so then we move to the definition of random variables. Why we would like to use random variables? Because I mean, in practice world, there are too many different types of random events, random experiments. They have different types of properties. We want to unify them into some more abstract space, right? That's why we introduced random variables. So random variables, I'm not going to talk about the rigorous definition, but you can view it as a mapping from some practical random things or random outcomes of interest to some numbers. Right? You can roughly view it like that, right? So we use numbers to represent the sample outcomes, and those numbers are called random variables. And the events can then be represented by random variables falling in some region. Right? For example, if we toss a coin, right, and to look at or to study the outcome, whether it got heads up or tail up, right, we can introduce the random variable x, right? X equals to 1, meaning that we see head, right? X equal to 0, meaning that we see tail up, right? Then we toss the coin for 5 times. We're gonna introduce 5 random variables, x1 to x5. Now we can use the values of those 5 random variables to represent all kinds of events. For example, if I want to represent an event that we see less than 3 heads, this event can be represented by this simple inequality, right? That is summation from x1 to x5 less than 3, right? And then we can evaluate what is the probability of this event. That is what something we often see in our textbook, right? The textbook asks us to compute, okay, what's the probability that your summation from x1 to x5 less than 3, right? Actually, it maps to some actual event in the real world. Does it make sense? Right. Okay. So if we look at the random variables, if we look at the random events and random variables, right, we need to be aware of some basic properties of them, right? So we can write down the joint probability of two events to happen, right, as P A and B, okay? And this P A and B, by the way, don't be confused, right? A and B are sets here, right? If you write P A and A comma B, it means the probability of P intersection with B, right? Don't get confused. It is not P A union B. Okay, so and the people are concerned about this, like what is the probability that both A and B happen? And we write their probability as a joint probability of A and B happen, right? And this joint probability can be decomposed as the marginal probability that A happens times a conditional probability that B happens given that A happens. Right? And symmetrically, it can also be decomposed as the probability that B happens times the conditional probability of A happens given that B happens. So this is the basic rule, right? And we can also extend the same decomposition to the random variables, right? So when we talk about random variables, we denote Pxy. We denote by Pxy the joint probability density of the random variables xy. This joint probability density can be decomposed of P of x times the conditional density of y given x. Right? Symmetrically, it can also be decomposed of P of y times the conditional density x given y. Right? I believe this is a formula everyone has seen before. Right? And also, we need to be aware of very important concepts called independence. Right? So conceptually, it means that two random events they're happening are now related to each other. Right? Whether they happen or not is not related to each other. Right? If we look at two events A and B, right? We say A and B are independent to each other if and only if their joint probability is the product of their respective marginal probabilities. Right? And similarly, if we say two random variables are independent, it means that their joint probability density is just the product of their marginal densities. If you contrast them to the definition of the joint probability, right, or joint probability density, what can we observe? We have another definition of the independence, right? So you can see that if A and B are independent, then their joint probability is PA times PB, but in general, definition should be PA times PB given A, right? So that means your conditional probability will be the same as the marginal probability. That also reflects A and B are independent. Right? And conceptually, it's reasonable as well, right? It's basically, okay, condition on A, the probability that B happens or not has nothing to do with A, right? So that's why we can go back to the marginal probability of B, right? Okay, conditional independence, right? It's just a generalization. It's just some extension of independence, right? So we just condition on those stuff on some third random variables or third events. And if it still satisfies such kind of decomposition, we see they are conditionally independent, right? So we say A and B are conditionally independent on C if and only if their conditional joint probability on C is the product of the conditional probability of A given C times conditional probability of B given C. Okay? And similarly, if two random variables x, y are conditionally dependent on z, that means the joint conditional probability density is the product of the conditional probability density x on given z times the conditional probability y given z. Okay, expectation, right? That's the most important property for random variable. That means on average, what is the value that a random variable can take, right? So its definition is just the integral of x itself with its probability density, right? And someone may ask, what if x is a discrete random variable, right? If it's discrete random variable, then you just replace the integral by summation, right? But usually, I mean, integral is just the limit of summation, so we can use them exchangeably, like for convenience. And we can also take expectation over a function of a random variable, right? Doing that is straightforward. In this integral, you can replace x by its function, and then you integrate with the probability density of x, you get the expectation of g of x. Okay. And the second most important property of a random variable is the variance. Right? So variance is basically means average how different the values of the random variable can take is from its expectation, right? And also you take some square on that, right? It basically shows that the perturbation of a random variable, right? So the definition of variance is expectation of x squared subtracted by square of expectation, right? And this is for the case that x is a scalar, it's an axis number, right? If x is a vector, then we can calculate so-called covariance matrix, right? The x is a vector of n dimensional, then the covariance matrix is n by n, right? So it is defined as expectation of x transpose, right? So this is a n by n matrix, right? Subtracted by the outer product of the expectation, right? The expectation now is vector, so the outer product will be matrix. And you can show that this covariance matrix is always semi-positive definite, right? So now I want to ask, what's the definition of conditional expectation? Any thought? Yes. Right? Yeah. So it's the same definition, except that okay, you're gonna replace the density here by the conditional density, right? You're gonna replace it by x given y, given y, right? You'll get this expectation of x given y, right? And in practice, you might consider different specific values of y, right? So now I want to ask, if you don't consider specific values that y can take, right? You just consider this is depending on y. So what is this expectation a constant or random variable? Why? Yeah, can you be more explicit? Yeah, that's very important. Right? Be careful. There's one problem in homework 0 asking you to properly understand this definition. Right? Remember, different values of y will lead to different conditional expectation. Right? So that means this conditional expectation essentially is a function of y, right? And remember, y is a random variable, its function must be a random variable as well. So this is a random variable, not a constant. And similarly, you can compute variance of the conditional variance of x given y, right? Again, this is a random variable of y. It's a function of y, so it's a random variable. Is there independent? Yeah. Yes. Yeah. But in general, you can view it as a function of y, right? And usually it's also a random variable. Right? Of course, this function can be a constant function. And in that case, okay, yeah, it's still constant. Right? Any other question? Great. Great. This is our basic review about the statistical concepts, right? Hope everyone feels comfortable, right? And next, we're gonna talk about the definition of convex function, right? Convexity. So convex function is a set of functions whose domain is defined on convex set or convex region. So what is convex region? So you can view this kind of this green shaded region as a convex region. Why? Because if you take up arbitrary 2 points in this region, right, you just connect them. You look at segment, right? You find that every point on this segment is still inside this region. Then this is a convex region. So that means any segment which connects 2 points inside the region, if it still belongs to the region, then this is a convex segment. And this is one example, right, which is not convex. This kidney shaped region. Why is not convex? Because if you take 2 point X, Y here, if you connect them, you see that the red part has been outside of the region. They no longer belong to the original region. So this is not convex. So convex function is defined on convex set. Okay. So what kind of function is a convex function? Right? First, the input domain is a convex region. And then for any 2 inputs in the input domain, right, and pick up any ratio between 0 and 1, if your function evaluated as a linear combination of x1, x2 based on this ratio t is less than or equal to the linear combination of the function values at x1, x2, then we say the function f is convex. This looks like a quite tedious and lengthy definition, right? We can illustrate with one simple graph. So what does this inequality mean, right? So this is your convex function f, right? So what does make it valid as being a convex function, right? We can pick up arbitrary 2 inputs in the input domain, x1 and x2 here, right? And we can pick up any ratio t between 0 and 1, right? So the convex combination or linear combination of x1 and x2 according to t will be some point in between x1 and x2, right? So the left-hand side of the inequality says that, okay, I'm going to evaluate my f value at this combination of x1 and x2 according to t, which is here, right? And the right-hand side of the inequality means that, okay, I'm going to first evaluate my function value at x1 and at x2, right? And then I do a linear combination of these 2 function values according to t, which should be here, right? So you can see that the combination of the function values actually is bigger than the function value at the combination of the inputs. Then we call such function f is a convex function. Yeah. This is a very simple family of functions, but has many nice properties. That's why, like in applied math, like this is kind of very fundamental, right? So there are many examples of convex functions. So here we just list a few, like exponential function, negative log function. This is a multivariable function, which are convex, like this is kind of linear function, or sometimes called affine function, are convex. Quadratic function, convex, right? So if we want to test or determine if a function is convex or not, right, we can, of course, test if, according to its definition, it is convex, right? We can also use several other criteria. For example, if this function f is differentiable, And if you can show that for any two inputs in a domain, your function is no less than fy plus the gradient at y times x minus y. Okay. Mm-hmm. Mm-hmm. Is what? If any function for any inputs x1, x2, and t satisfies inequality, it is defined as a convex function. So to check if a function is convex or not, you just need to check this inequality holds or not. No, you cannot say. You need to make sure that every possible choice x1, x2, and t, this inequality holds. Uh-huh. Uh-huh. Mm-hmm. No, it's not possible. You can, yeah, you can try to enjoy it after class. It always satisfies. Yeah. Yeah, you can draw arbitrary 2 points for this kind of curve. You always see that. Mm-hmm. Yeah, because the combination of the function value is always above the function line, function curve in between x1, x2. That's why you want to, yeah. But it's just to give you, it's not rigorous proof. If you want to prove that, okay, you need to rigorously show that for arbitrary x1, x2, and arbitrary t, this inequality holds. X1 must be what? No, not necessary. Yeah, because, well, for one dimensional, you can see x1 less than x2, right? But what if like multi-dimensional, right? It's hard to see if your input x1 is less than input x2, right? Yeah, that's why I say, okay, for arbitrary x1, x2, there's no order restrict, right? So here I just want to share like two commonly used and perhaps more convenient standard to test if a function has convex or not. First, you're gonna test this. Second, if this function is twice differentiable, we just test if for any input in the input domain is hash matrix a positive semi-definite. Okay, so we'll explain what's the geometry meaning of this in the next lecture. What? Just one. Any of them will be fine. There are a lot of usage. For example, for support vector machines, you see its optimization heavily relies on the properties of convex function. And also, if you want to extend, because SVM was initially developed as a linear classifier, you want to extend to nonlinear classifiers through kernel trick. That means you have to convert into the dual space. And this dual problem, the formulation is all based on the convex properties. It's related to the so-called KKT conditions, which we're going to discuss later. Okay, yeah, let us, sorry for we're late for a few minutes, but thanks for those great questions. So let us continue our discussion on Thursday.